Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us to a land of silence so vast, so untouched, that it feels almost like a secret the Earth has been keeping. We're heading south, farther than planes usually fly, farther than most ships dare wander, to the last truly still place on this planet, Antarctica. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into this frozen continent together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. Antarctica is a place so silent, so vast, that it almost resists being known. It stretches over 14 million square kilometres, more than the United States and Mexico combined. Yet most of it has never felt a human footprint. There are no cities here, no trees, no roads winding between houses, only the wind, the ice, and the long memory of snow falling endlessly on snow. If Earth has a sleep mode, this is it. And yet, beneath that apparent stillness, there is movement. Slow, deep, powerful movement. The kind that happens over centuries and millennia, shifting glaciers, carving out basins, forming valleys and hiding entire mountain ranges from view. It's as if the land itself is holding its breath, an entire continent wrapped in a blanket of frozen time. You might think of Antarctica as a blank space at the bottom of the map, a white smear at the edge of known places. But it's not empty. Far from it. It's full of stories we've barely begun to hear. Stories written in layers of ice, in the shadows of buried mountains, in the whisper of lakes sealed beneath the surface for millions of years. This is a continent that remembers things we've long forgotten, or perhaps never knew at all. And it's strange to think, while most of the world bustles with noise and haste and electric light, this place remains largely untouched. It sleeps, not in the way a person sleeps with dreams and restlessness, but with the stillness of something ancient and enduring, something outside of time as we know it. When explorers first stumbled upon the edges of this frozen land, they thought it lifeless, desolate, nothing but cold and ice and wind. But now we know better. The real story of Antarctica is not one of emptiness, but of hidden fullness. Beneath the miles of ice lies an entire world, mountains as tall as the Alps, lakes as large as Ontario, rivers that still flow in total darkness, and strange forms of life clinging to existence in places where no sunlight ever reaches. And above the surface, in the icy blue air, life has found a way too. Penguins raising their young through howling winters, seals diving beneath frozen seas, and tiny krill blooming in the cold southern ocean, feeding whales that glide through water like slow-moving planets. But tonight, we're going deeper than that. We won't stay on the surface for long. Instead, we'll sink softly downward, like a snowflake falling through time, past the frozen windscapes, past the jagged crests of glacial cliffs, down into the ancient ice, where layers of snowfall have been compacted into glassy sheets, each one a frozen breath from an age gone by. Beneath that, into the blackness where no light has touched for millions of years. Our question is simple. What lies beneath? It sounds like the beginning of a ghost story, but it's really a science story. A story of pressure, of silence, of waiting. A story that stretches back to a time when Antarctica was green, filled with forests, rivers, and creatures we've only met through fossils, and a story that stretches forward into our own uncertain future, As the ice begins to melt and the past begins to surface, the secrets beneath the ice aren't just geological, they're emotional. Because in some quiet way, Antarctica reflects us. Our curiosity, our ambition, our fears, and our deep, almost instinctive yearning to find out what's hidden, even if we're not sure we want to know. So as we begin this journey, think of Antarctica not just as a place on the map, but as a kind of mirror. A mirror that doesn't reflect our faces but our questions. A place where the Earth has hidden its oldest memories, and where we, as a species, now stand, listening quietly for what the ice might whisper back. Sleepy science is not about rushing to answers, it's about drifting gently through wonder, about lingering in the quiet and letting that quiet change you. So, let's take the first step, soft and slow. Let's begin at the surface, where the ice stretches like a second sky, and from there, we'll descend. The thing about ice, real ice, not the kind in your glass or clinging to a winter windshield, but the kind that blankets a continent, is that it doesn't just sit, it waits. And in waiting, it remembers. You might think of ice as cold and still, but that stillness is deceptive. Beneath its quiet surface, ice is one of the greatest archivists Earth has ever known. Each snowfall that settles on Antarctica doesn't just vanish. It joins a stack, layer upon layer, flattened and squeezed and frozen until it becomes part of something vast, something deep, something ancient, a record of time, not in ink or sound or image, but in frost. The Antarctic ice sheet is the largest single mass of ice on Earth, stretching across nearly 14 million square kilometres and, in some places, reaching depths of over 4 kilometres. That's not just distance, that's memory. Millions of years of pressure and snow, all compressed into a sleeping history we're only beginning to read. And when we say it holds the past, we mean that literally. Trapped inside that ice are tiny bubbles of air. Ancient atmospheres from thousands, even hundreds of thousands of years ago. Each bubble a soft exhale from a world long vanished. If you were to drill down into that ice gently, carefully, you'd be taking a kind of core sample of time itself. A frozen cylinder, perhaps no thicker than your arm, but stretching back through ages. Ice that fell when mammoths still walked, when forests covered deserts, when the human story was still a whisper in the dark, and when scientists hold that ice in their hands, they're not just seeing frozen water, they're holding a moment, paused, a breath from a younger planet. In this way, Antarctica is more than a place. It is a time machine, locked in crystalline slowness. It preserves the shifting of climates, the rise and fall of carbon in the air, the long rhythms of Earth's heartbeat. There are records in the ice of volcanic eruptions, of great droughts, of the dance between glacial ages and warm interludes. It's a kind of memory that isn't felt, but measured. Not remembered, but revealed. And yet, it's not loud about it. The ice doesn't cry out, it doesn't advertise what it holds. You have to ask gently. You have to listen carefully. Because Antarctica doesn't share its secrets with those who rush or shout. It speaks only in stillness. The silence here isn't just the absence of noise. It's a presence in itself. A fullness. It wraps around you like a heavy blanket, dampening even your thoughts. Out on the ice shelf, you might hear only the wind, a distant crack, the soft crunch of your own boots if you're lucky enough to walk there. No bird song, no cities, no engines, just cold air and open space and the long hush of time unfolding. That silence is not empty. It's the kind of quiet that has weight, that asks you to slow down, to notice, to feel the way a snowflake lands, not just that it did. It's in this quiet that the continent holds its dignity. Not proud or forbidding, just resolutely, peacefully unbothered, as if it has seen too much to be impressed and too much to be afraid. And still, We try to understand it. We send planes overhead with radar that can see beneath the surface. We lower probes into ice cores, reading layers like the rings of trees. We map it inch by inch, year by year. And even though it yields some answers, the ice is never done being mysterious. There's always one more layer, one more echo, one more buried whisper. To stand above all of that, above mountains smothered in frost, above lakes sealed in darkness, above air bubbles from ages ago, is to feel very small. But not in a frightening way. More like the way you feel when you look up at the stars. The world is bigger than you, older than you, quieter than you. And that's oddly comforting. The ice reminds us that slowness is not stagnation, that stillness is not the absence of meaning. Sometimes the most important truths are the ones that take the longest to surface. Antarctica is not a place of dramatic revelations, it's a place of patience. And maybe that's why it holds so much. And so, we prepare to go deeper. We've stood on the surface now, felt the cold, seen the vastness, heard the silence. It's time to descend. Not just in space, but in understanding. What lies beneath this vast white plain? What forces shape it from below? What forms of life might be hiding where light has never reached? We'll begin with the landscape beneath the ice. Not the ice itself, but what it conceals. A shadow continent within a frozen one. Beneath our feet, though we can't feel it, are ridges and valleys, mountain ranges and riverbeds, lakes and volcanoes, all hidden beneath miles of ice. The real Antarctica, in a way, is the one we cannot see, and so our descent begins, not with a fall, but with a deepening, a slow and careful drift downward, through pressure, through layers of ancient snow, past memory and mystery. We are not drilling through ice, we are slipping into story. Beneath 4 kilometres of Antarctic ice there is a mountain range no one has ever seen. Not with eyes, at least. It doesn't rise above a skyline. It casts no shadow. There are no birds nesting on its peaks, no rivers flowing through its valleys, no clouds brushing along its ridges. In fact, if you stood directly above it, boots planted on what looks like a flat, empty ice sheet, you'd feel nothing beneath your feet but the hush of the wind and the press of cold. You wouldn't know that deep below the earth is folded into something as large as the Alps, but it is. The Gamburtsev Mountains, a range as mysterious as it is massive, hidden in full beneath East Antarctica like a cathedral swallowed by snow. And for decades, no one even knew they were there. They were discovered not by footsteps or explorers with notebooks, but by sound, specifically by radar. Pulses sent from aircraft, which echoed off the terrain below the ice and returned with a faint message. There is something enormous here. The idea of a mountain range that vast, completely buried and undetectable by sight was at first hard to accept. But the data didn't lie. Beneath the icy crust was a hidden continent within the continent, and at its centre a spine of stone rising into the dark. Scientists describe the Gamburtsev Mountains as a ghost range, not because they're haunted, but because they're present in shape but absent in light. No sun has touched them in millions of years. No human has walked between their cliffs or measured their height directly. And yet we know they are tall. Some peaks may reach nearly 3,000 metres. We know they're vast, stretching over 1,200 kilometres, and we know they are old, formed over 1 billion years ago during the collisions that assembled Earth's ancient supercontinent, Gondwana. But the mystery runs deeper than just their hidden location. What puzzles geologists is not just that these mountains exist, but that they still look like mountains at all. Over 1 billion years, most mountain ranges are worn down by erosion, weathered by wind and rain, and reduced to stumps of their former selves. But not the Gamburtsev. They are sharp, jagged, almost young in shape, and yet they are not young. So how did they keep their form? One theory suggests that long after they first rose they were rejuvenated, lifted again by tectonic activity deep underground. Another possibility is that the ice itself preserved them, that once the glaciers began to grow and stretch across the land, they locked the mountains beneath a kind of frozen time. No rivers flowed to wear them down, no trees grew to crack their surfaces, no frost thawed and refroze in their crevices. They were entombed, not destroyed, but protected. In that way, the ice became not just a barrier but a guardian, and the mountains beneath it became fossils of elevation, still standing, still grand, but sealed away. It's a poetic reversal of what we expect from time. Usually time erodes, but here time is preserved. To imagine the Gamburtsev Range is to imagine a cathedral built in secret, a place of quiet pillars and unseen vaults, resting in darkness. No stained glass, no echoing songs, just the pressure of ice above and the silence of geology below. In this way, the range feels almost like a memory Earth has decided not to forget. And what makes this even more humbling is that we only discovered it by accident. During the International Geophysical Year in 1958, scientists were conducting seismic surveys to understand the thickness of the ice. They expected to find bedrock, flat, maybe gently sloping. Instead, they found an alpine skyline beneath the ice, a secret spine. Since then, radar mapping has painted more detailed pictures of the hidden range. Computers have recreated topographical maps showing ridges and peaks, valleys and basins, but no image is perfect. We're still guessing at the colours, the textures, the feel of stone. We can't say for certain what type of rock composes its core, or whether ancient rivers once ran between its flanks. What we do know is that it lies at the very heart of East Antarctica, beneath one of the coldest and thickest ice sheets on Earth, wrapped in darkness and pressure. And yet, even in this isolation, the Gamburtsev Range may have shaped everything around it. Some scientists believe the mountains helped form the first major ice cap on Antarctica. Their high peaks may have served as gathering points for early snowfall, anchoring the growing glaciers. Over time, as snow became fern and fern became ice, the glaciers grew outward, fed by gravity and cold. In this view, the range isn't just a hidden feature, it's a birthplace, a silent architect of Antarctica's icy crown. There's something haunting about a mountain that no one will ever climb, something profound in knowing that entire ranges of stone can rise and fall and never be seen. And yet, maybe that's what makes the Gamburtsev Mountains so compelling. They remind us that discovery doesn't always happen through footprints or flags. Sometimes it happens through patience, through echoes, through listening. And so, as we drift onward in our journey, we leave these dark peaks behind, not because they have nothing more to offer, but because we've only just begun. There are deeper places still to visit, valleys lower than any trench, lakes sealed beneath time, volcanoes sleeping beneath frost. The continent has many stories, and we're only now learning to hear them. If you were to draw a line across the Earth's surface searching for its lowest point of land, not beneath oceans, but actual solid ground, you might expect to find it in some yawning canyon, some great valley riven by time and tectonics. But you would be wrong. That deepest known point isn't in Africa or Asia, not even on the seafloor. It lies here, in Antarctica, in a place hidden from view, sunken beneath an ice stream so remote that it wasn't even properly mapped until recent decades. This place is called the Denman Glacier, and under its frozen weight lies a trench, a chasm more than 3,500 metres below sea level. That's deeper than the Grand Canyon, deeper than Death Valley. It is the Earth's lowest exposed continental crust, yet it is invisible, buried under kilometres of ice, and it is moving. The Denman Glacier is no static feature. Glaciers are rivers of ice, and Denman is among the most concerning. Unlike some glaciers that melt only at the surface, Denman is being eroded from beneath. Warm ocean water, sliding in along narrow unseen pathways beneath the floating ice shelf, is slowly chewing away at the glacier's base. This process, known as basal melting, is nearly impossible to witness directly. But satellites have shown its effects. The grounding line, the invisible boundary where the glacier detaches from the bedrock and begins to float, has been retreating, quietly but steadily. Since the late 1970s, Denman's grounding line has pulled back nearly 5 kilometres. That might not sound like much, but in glacial terms, it's the kind of movement that draws the attention of every climate scientist with a satellite feed. It suggests not just loss, but instability, a tipping point. If the retreat continues, and especially if it accelerates, it could lead to a slow, cascading collapse of the entire glacier, releasing massive volumes of ice into the Southern Ocean. But Denman is not just significant because of what it's doing now. It's also important because of what it might hold. The trench beneath Denman is a basin, a massive catchment where ancient sediments have likely accumulated for tens of millions of years. Sediments from warmer times, from when Antarctica was not frozen, but forested, when rivers ran across its surface and life flourished in places that are now silent and sealed. If we could access those sediments, we might find traces of long-vanished ecosystems, perhaps even microfossils or ancient biomarkers that could tell us what this continent looked like before the deep freeze began. Imagine it. A fossilized pollen grain, embedded in the clay at the bottom of the world. A leaf imprint. The ghost of a fern. All waiting in a depth we can't see. Beneath a glacier we're only just beginning to understand. Denman is often described in quiet terms by the scientists who study it. Asymmetrical, unstable, topographically vulnerable. These are not dramatic words, but they carry weight. Denman's shape is steep on one side and sloping on the other, like a bowl slowly tilting. If melting continues, that tilt could accelerate ice loss, feeding a loop where the glacier becomes thinner, floats more easily, and allows more ocean water to slip beneath. The deeper the basin, the more likely this process becomes unstoppable. In that sense, Denman is not just a trench. It's a throat. A narrowing, receding space through which part of Antarctica may one day pour. It is easy, and perhaps tempting, to imagine Antarctica as unchanging, its coldness as permanence. But Denman reminds us that even here, where time seems frozen, motion never stops. Still, the glacier makes no sound we can hear. It doesn't warn us in words. It creaks and cracks on frequencies too low to notice. And yet it speaks, if we listen in the right ways. Satellite altimetry, ice-penetrating radar, oceanographic surveys, all of them like stethoscopes pressed to a patient who does not complain, but whose vital signs tell a different story. Scientists sometimes talk about Antarctica as a sleeping giant. If that's true, then Denman Glacier might be the giant's breath, slow, deep, and starting to shift. And yet, for all the danger it represents, Denman is also a place of strange, hidden beauty. The trench it covers is not empty. It is sculpted. Beneath the glacier, the land is shaped like a winding canyon, with overhanging cliffs and hollowed chambers. No light reaches these shapes. They have never seen the sky. But they exist, carved not by water but by ice grinding slowly over stone. Like an invisible hand tracing furrows into the bedrock over millennia. One day, if technology allows, we may reach down through the ice to study this terrain more closely. We may lower submersibles into hidden fjords, pull up cores of ancient mud, scan the rocks for the fingerprints of prehistoric rain. But for now, Denman remains a mystery that reveals itself in inches, retreating, melting, changing, and reminding us that nothing on Earth is ever truly still. So as we drift onward in this quiet journey, let us carry the image of a glacier that hides the deepest wound in the Earth's crust, a place where silence presses down harder than air, where the cold is not just temperature but memory, and where something ancient may yet be waiting beneath the melt. Imagine a lake so old that it hasn't seen the sky in over 1,000,000 years. A lake that lies not beneath clouds or soil or even bedrock, but beneath a solid wall of ice, thicker than the height of most mountains. There, in the darkness, isolated from wind, from sun, from time, it waits, sealed like a letter from a forgotten century, its contents untouched, its silence unbroken. Welcome to the world of Antarctica's subglacial lakes. These lakes are some of the most isolated environments on Earth. They exist beneath kilometres of compressed ice, kept liquid not by sunlight or warmth from above, but by geothermal heat rising faintly from the Earth's crust and the immense pressure from the ice itself. That pressure lowers the freezing point of water, and with just enough heat trickling upward, these lakes remain fluid, even as the surface above freezes solid year after year, century after century. There are over 400 subglacial lakes that we know of, scattered beneath the Antarctic ice sheet like buried stars in a frozen sky. But the most famous of them all is Lake Vostok, a giant, dark body of water larger than Lake Ontario, lying more than 4 kilometres beneath the surface of East Antarctica. It was discovered through radar imaging in the 1990s, and its sheer size, more than 250 kilometres long, was enough to stop scientists in their tracks. But what truly captured their imaginations was what might live inside it. Because you see, these lakes has been completely sealed off from the atmosphere for possibly millions of years. No sunlight penetrates that depth. No oxygen seeps in from the air. They are shielded from seasonal change, from wind, from surface microbes, from contamination of any kind. And yet, conditions inside these lakes suggest that life might not just survive there, but thrive. Take Lake Whillans, for instance. Unlike Vostok, which remains largely untouched, Lake Whillans was successfully drilled and sampled in 2013 using a clean hot water drill system. One of the most careful and sterile operations ever performed in glaciology. When researchers retrieved water and sediment samples from the lake, they found something quietly extraordinary. Living microbes adapted to total darkness, low temperatures, and extreme pressure. These tiny organisms were not dormant. They were active, metabolizing, reproducing, surviving on energy drawn from minerals in the sediment rather than light. In the absence of photosynthesis, life had found another way. And in doing so, it had rewritten part of what we thought we knew about where and how life can exist. It raises an even deeper question. If life can survive here, beneath the crushing weight of an ice sheet, with no sunlight, no plants, and no open water, could it survive in similar environments beyond Earth? Some of the most promising candidates for extraterrestrial life are not planets like ours, but icy moons, Europa, orbiting Jupiter, or Enceladus, orbiting Saturn. These moons are frozen on the outside but believed to have liquid oceans beneath their icy crusts, warmed by internal heat. They may be, in many ways, analogues to the subglacial lakes of Antarctica. If microbes can live in Lake Whillans or Vostok, might they also exist in those alien oceans? Antarctica, then, becomes more than a place of earth science. It becomes a kind of proxy for astrobiology, a place where we test our instruments, our ideas, and even our imaginations. But getting into these lakes, truly studying them without contaminating them, is a challenge that demands extreme care. Scientists must avoid introducing foreign microbes, chemicals, or even air into these sealed systems. Drilling operations involve high-pressure hot water, triple sterilisation, and real-time contamination checks. It's like performing surgery through a 4-kilometre-long keyhole, blindfolded, in gloves. Lake Vostok remains largely untouched for that reason. Russia's drilling efforts reached its upper layers in 2012, but controversy remains over how clean the operation was. The fear is that if we enter carelessly, we may alter or destroy what we came to study. So for now, Vostok keeps its secrets, and maybe that's all right. Some letters aren't meant to be opened quickly. Still, there's hope that one day we'll access these lakes more safely, with robotic probes, cleaner drilling systems, or perhaps even by entering the smaller lakes first, learning as we go. The lakes are not in a hurry. They've waited this long, and their patience is part of what makes them beautiful. To picture one of these lakes, don't think of bright water beneath sunlight. Think instead of black, glassy depths, walled on every side by ancient ice, water that hasn't stirred in millennia, a world where every molecule has been shaped by silence, where life, if it exists, is life at the very edge of what is possible, and yet it is that very edge that teaches us about resilience, about what matters for survival, about the limits of biology, and how those limits might be broader than we thought. So tonight, as you rest in warmth, consider that beneath your feet, near the bottom of the world, there is an invisible sea, a place without sky, without sound, without time as we know it, a place that might hold the memory of Earth's deep past and the hint of life's far future, and it's waiting, silently, patiently, sealed in a continent of ice. When you think of Antarctica, you probably picture an expanse of cold so complete that even fire itself would flee from it, a place of whiteness, wind, and stillness. But nestled within that stillness there is a contradiction, a place where fire does not flee, but lives. Deep within the vast sleep of the southern ice lies a beating heart of heat, pulsing not quickly, not loudly, but steadily, like an ember glowing beneath a blanket of snow. That ember is Mount Erebus. Located on Ross Island, Mount Erebus is one of the southernmost active volcanoes on Earth, and one of only a handful with a persistent lava lake glowing in its summit crater. While the rest of the continent sleeps in cold silence, Erebus simmers, its lava bubbling, steaming, breathing. It is a paradox, a volcano that survives not in a tropical basin or along a ring of fire, but in a land where temperatures plunge below -50 degrees Celsius, where the sun disappears for months at a time, and where life clings only to the edges. Erebus was discovered in 1841 by British explorer James Clark Ross, who named it after one of his ships, itself named after the Greek personification of darkness, and that's fitting, because Erebus is indeed a creature of darkness. Its fire does not roar. It murmurs, quiet, steady, almost contemplative, as if it knows its place is unusual, and yet it stays, a rare fire in the kingdom of frost. But Erebus is not alone. Beneath the Antarctic ice sheet, geologists have detected a field of volcanoes, many of them long dormant, others possibly still active. Using radar and remote sensing, scientists have identified over 100 volcanoes beneath the West Antarctic region alone. Some are tall, others stunted, many completely buried beneath ice that is thousands of meters thick. Unlike the dramatic eruptions we see in other parts of the world, these volcanoes shape their environment slowly, often invisibly. So how can fire exist beneath all that ice? The answer lies in the planet itself. Deep below the crust, geothermal heat rises slowly from the mantle. It's not explosive, more like a constant exhalation. In places where the crust is thinner, or where ancient volcanic systems remain warm, this heat can collect and build. Over time it warms the base of the ice sheet from below, sometimes creating pockets of water, softening the ice or altering its flow. This process doesn't melt Antarctica from the surface downward, but from the base upward, a hidden warmth, shaping things in silence. In areas like Marie Byrd Land, this geothermal activity may be contributing to instability in the ice sheet. While surface temperatures remain deeply cold, and even snowfall persists, the underside is loosening. It's a reminder that what seems stable from above may be quietly shifting from below. A kind of geologic metaphor, perhaps, for all the things we don't see, but are still moving. Back at Erebus, the story becomes even stranger. The volcano isn't just an anomaly for its location, it's unusual in character. Its lava is rich in carbonatite, a rare type of molten rock that flows more easily than most, and its gas emissions contain trace compounds that help researchers study the composition of Earth's deep interior. Instruments placed around the crater measure everything from seismic tremors to atmospheric chemistry, and even the shape of the lava lake's crust as it shifts and cracks under pressure. Scientists who work there describe a surreal landscape. Steam rising into a sky of pale blue, snowflakes melting instantly on the crater's edge, the hiss and pop of lava heard through icy air. It's like standing at the boundary between two worlds, fire and frost, heat and silence, movement and stillness. But even more than its spectacle, Erebus offers insight. Volcanic heat may seem like a fringe character in Antarctica's story, but it plays a quiet, powerful role. It affects how ice flows, how lakes remain liquid, how glaciers respond to stress. In a continent where everything is shaped by cold, heat becomes the exception that writes the rules, and in a wider sense, these volcanoes remind us that Earth is always balancing. Beneath the calmest landscapes there is tension. Beneath the quietest places there is breath. Nothing is ever truly static, not even ice, not even mountains, not even Antarctica. There's something oddly comforting in that, in knowing that, deep under the coldest place on the planet itself is still alive, still warm, still glowing. That even where nothing grows, something burns. That life on Earth and Earth itself are never without motion, even if that motion is slow and unseen. So as we prepare to leave this place of fire wrapped in frost, remember that not all warmth is visible, not all movement is loud, and not all stories are told in the open. Some stories, like Erebus, flicker quietly in the dark. If you close your eyes and imagine a world with no sun, no sky, and no air to breathe, a world sealed off by 4 kilometers of ice, silent for 1 million years, you might think such a place would be empty, sterile, dead. But beneath Antarctica, in these dark and ancient lakes buried in glacial stillness, life has found a way to whisper. The discovery came not with a shout, but with a cautious hum of machinery, a sterile drill, and a few precious drops of water drawn from Lake Willans, a subglacial lake hidden far below the West Antarctic ice sheet. The mission was careful, almost reverent. Scientists knew that what they found, if anything, might change how we define where life can exist. And what they found were microbes, living ones, active, feeding, dividing, completely adapted to a world with no light. These tiny beings survive without photosynthesis. They don't rely on sunlight, on chlorophyll, or on oxygen as we usually know it. Instead, they draw their energy from the rocks and sediments beneath them, using iron, sulfur, and other minerals as fuel. It's a metabolic strategy known as chemosynthesis, a kind of underground alchemy where life survives by extracting energy directly from the bones of the planet itself. In a way, these microbes live more like deep-sea vent organisms than surface dwellers. They don't need the warmth of a star. They live in total darkness, under crushing pressure, in water that never sees the surface, and yet they live. Some are bacteria, others are archaea, a group of life forms so old and so unique that they form their own domain, separate from plants, animals, or fungi. They are the quiet ancestors of life on Earth, and possibly its most enduring residents. In Lake Willans, these organisms don't just endure, they thrive. Not in great numbers, not with visible bloom, but with the slow certainty of something that has adapted completely to its niche. Like candle flames burning steadily in a stone chamber. It's tempting to think of this as extreme life, but to the microbes, it's just life. They don't know they're exceptional. They aren't waiting for the ice to melt. They've carved out an existence in one of the coldest, darkest places on Earth, and they are content. And this contentment, this quiet success, opens a door to new thinking. Because if life can emerge and evolve here, where there's no sunlight, no plants, no obvious food, then where else might it be hiding? We often imagine that life requires very specific conditions: warmth, liquid water, sunlight, air. But these discoveries in Antarctica suggest a wider, stranger definition of habitability, one that doesn't care about the surface, one that thrives in silence. It changes how we look at planets like Mars, which has frozen underground aquifers, or Europa, Jupiter's icy moon, where a subsurface ocean is believed to slosh beneath a thick shell of ice, or Enceladus, Saturn's shimmering moon, which sprays geysers of liquid water into space from cracks in its crust. These are places without forests or rivers, without beaches or bees. But if Earth can nurture life beneath glaciers, then so might these distant frozen worlds. They might have their own Willans, their own sealed lakes, their own microbial stories unfolding in the dark. Back in Antarctica, we are still at the beginning of understanding. Lake Mercer and Lake Vostok, even larger and deeper than Willans, remain mostly untouched. Drilling into them is hard, not just technically, but ethically. How do you explore something without breaking it? How do you study life without altering it? How do you visit a place that has never known us, without leaving a footprint? That's why subglacial research is done with such care. Drills are sterilised, sampling equipment is flushed and cleaned repeatedly. Hot water is used instead of conventional machinery, so the access tunnels are cleaner and the risk of contamination is minimised. Even so, every step is taken slowly, like walking into a cathedral where something sacred might be sleeping. And perhaps it is. Not sacred in a spiritual sense, but in the sense of being untouched. These microbes are the product of isolation. They've lived without interference, without noise for hundreds of thousands, perhaps millions of years. And that makes them precious. They may hold biochemical secrets we haven't seen before, new enzymes, new survival mechanisms, clues about Earth's early past when life first emerged not on the surface, but in deep, shadowed places. Studying them may help us develop tools for medicine, or for cleaning up pollution, or even for protecting spacecraft from radiation. They may be tiny, but they're not irrelevant. In fact, they might be telling us something profound, that life does not need permission to begin. It only needs a chance. And where there is water, energy, and time, even in the cold, even in the dark, life may arise. It may not bloom, it may not walk or speak, but it may shimmer faintly in a single cell, dividing slowly, resisting extinction. A tiny light, unnoticed but unextinguished. So tonight, as you breathe the air around you, warm and bright with human comfort, remember that deep beneath the ice, in a place no one has seen, life goes on. It does not know our names, but it exists, and it is enough. Some forms of life bloom in gardens, others settle in forests or in warm, shallow seas. But there are those, rare, strange and quietly determined, that choose different homes. They do not ask for sunlight or comfort. They survive in places where others cannot. Places where cold bites into every surface, where radiation splits molecules, where pressure builds like silence in a locked room. We call these beings extremophiles. The word itself means lovers of the extreme, though that's a bit poetic for creatures that seem more like stubborn monks of the microbial world. In Antarctica, extremophiles are not fringe outliers. They are often the norm. From subglacial lakes to dry valleys that haven't seen rain in centuries, from ancient permafrost to patches of exposed rock blasted by ultraviolet light, these organisms thrive in places that, by most definitions, shouldn't support life at all, and yet they do. Not just in Antarctica, but in other hostile corners of the world too. Boiling acid pools, deep-sea hydrothermal vents, the frozen deserts of the Arctic. But nowhere gathers more extremes in one place than Antarctica. Here, life must contend with cold, pressure, salinity, desiccation, darkness, and a near-total lack of nutrients. And somehow, life replies not with surrender, but with innovation. Consider a tiny microbe embedded in the ice, no larger than a speck of dust. It may have been frozen for centuries, held in suspended animation, its molecular machinery slowed nearly to stillness. And then, given a single drop of meltwater, a whisper of liquid, it stirs, it repairs its own damage. It breathes, in the microbial sense. It divides, it goes on. Some of these microbes can repair broken DNA, patching themselves back together after exposure to UV radiation or extreme dryness. Others change the composition of their own membranes to remain flexible in bitter cold. Some produce antifreeze proteins, tiny molecules that bind to ice crystals and stop them from expanding, like placing soft gloves on jagged glass. A few can survive both freezing and drying, cycling between dormancy and activity depending on what the world allows, and their resilience extends beyond the body. These organisms often carry with them genetic clues to their history. Their DNA, passed down in quiet loops over thousands of generations, may contain blueprints for biochemistries we have yet to understand. Enzymes that work in ice, repair systems that defy radiation. It is life not only enduring, but evolving to make hardship its habitat. It's humbling in a way. While we humans bundle ourselves in layers, build heaters, carve shelter from storms, these tiny organisms endure without any of that. They do not resist the cold, they accept it. They flow with it. They become, in some quiet sense, part of the frost itself. In the McMurdo dry valleys, one of the driest places on Earth, microbes cling to the underside of translucent rocks. Here, they find just enough moisture from melting frost, just enough light filtering through stone to photosynthesize for a few precious hours each year. It is not abundance, it is barely survival, and yet it is enough. Some extremophiles in Antarctica are so durable that they've been sent into space, on purpose. In controlled experiments aboard the International Space Station, scientists exposed Antarctic microbes to the vacuum, radiation, and temperature swings of low Earth orbit. Many survived. Not all, but enough to make us wonder, if life can survive the edge of space, perhaps it can travel between planets, protected in dust or ice. Perhaps extremophiles are not just survivors, but explorers. And this brings us gently to a broader reflection. When we think about alien life, we often imagine something dramatic. A writhing creature, a glowing being, a strange intelligence watching from afar. But the truth is likely quieter. If life exists beyond Earth, it may begin as it did here, in smallness and silence, in microbes curled against warmth inside ice, in chemical whispers beneath frozen oceans, in extremophiles that do not speak, but endure. What Antarctica teaches us is that resilience doesn't always look heroic. Sometimes it looks like stillness, like patience, like survival by the thinnest thread. And that thread, impossibly, holds. These organisms are not here to inspire us, but they do. Because in their quiet way they remind us that life is not a delicate thing. It is a persistent thing. A thing that will try, again and again, to find a way through, even if that way is narrow, cold, and completely unseen. And so, when we peer into the frozen lakes of Antarctica, or scan the subsurface oceans of Europa, or search for warmth beneath the frost of Mars, we're not just asking whether life could exist. We're asking whether persistence itself is a universal law, whether the will to endure is woven into the fabric of biology, whether somewhere far away something small and stubborn is also holding on. Tonight you're not just listening to the story of microbes, you're listening to the story of life's deep, quiet determination. A determination that does not roar or rush, but waits, breathes, and stays. Below the ice, life whispers in the dark. But above it, on the snow-laced coasts in the icy waters and across the frozen plains, life walks, swims, sings and survives with a kind of quiet drama. These are not microbes or hidden cells. These are creatures you can see, whose breath mists in the cold, whose eyes reflect Antarctic twilight, and whose lives are spent navigating a world where survival requires exquisite timing, deep memory, and deep resilience. Perhaps none is more iconic or more improbable than the emperor penguin. These birds do not fly through the air but through the sea, gliding with impossible grace. On land they waddle, hop, and shuffle with a determination that sometimes borders on the ridiculous, and yet it's precisely this awkward resilience that defines them. Emperor penguins live the coldest breeding life of any animal on Earth. They choose to raise their young in the depths of the Antarctic winter, when temperatures fall below -60 degrees Celsius, when winds howl across the ice sheet, and when the sun vanishes for months. Why? Because this harsh timing gives their chicks the best start when the brief summer returns. It's a decision written not in strategy, but in instinct, a rhythm woven into their bones. After laying a single egg, the female passes it carefully to the male, who balances it on his feet and tucks it under a fold of skin. There the egg is kept warm not by environment, but by the steady heat of his body. And while the male stands vigil, for weeks, motionless, fasting, enduring, the female returns to sea to feed. Thousands of males huddle together for warmth, swaying gently in a synchronized slow-motion shuffle. It is not chaos. It is a choreography of patience. When the egg hatches, the chick emerges into a world of biting wind and endless white. Yet, somehow it finds warmth in a parent's feathers, food in a returning mother's beak, and safety in a colony that knows how to endure the unendurable. The entire life cycle of the emperor penguin is a masterclass in survival against the odds, and they are not alone. Out along the coastline and beneath the sea ice, another specialist waits, the Weddell seal. These seals are among the deepest diving mammals in polar regions. They swim beneath the ice in utter darkness, navigating by memory and sound, holding their breath for over an hour at a time. To stay beneath the frozen ceiling, they must maintain breathing holes in the ice, scraping them open with their teeth. Over time, the work wears their incisors down. In old age, some seals die not from predators or starvation, but from the inability to chew through ice. It's a fate as cold and poetic as the landscape itself. But while emperor penguins and Weddell seals draw the eye, there are smaller lives, quieter but just as vital, swimming unseen beneath the surface. Antarctic krill, tiny shrimp-like creatures, form the base of the entire Southern Ocean food web. They gather in vast swarms, sometimes so dense they can be seen from space, and feed on the microscopic algae that bloom under the sea ice during summer. In turn, they become food for fish, for seals, for whales. Yes, even the great whales, humpbacks, minkers, blues, visit these frozen waters, diving deep to scoop up krill by the mouthful. It's a stunning contradiction. The world's largest animal sustained by some of its smallest, and all of it balanced delicately, season by season, in a system that relies on the precise timing of ice, sun, bloom, and melt. Above the water, the air is alive with birds, snow petrels, skuas, sheathbills, all adapted to the cold, all moving in synchrony with the changing seasons. Many travel vast distances to reach Antarctica's shores, drawn by the abundance of summer, but even the summer is short, and the margin for survival is thin. That margin is growing thinner. Climate change, though often spoken of in degrees and models, is felt here in timing, in melt dates, in sea ice coverage, in the changing rhythms of bloom and freeze. For emperor penguins, it means thinner ice platforms to breed on, and in some regions a declining chance of chick survival. For krill, warmer waters and shifting currents may disrupt their feeding grounds. For seals and birds, changes in ice coverage can mean fewer resting spots or altered migration patterns. And because everything here is connected, from the algae to the krill to the whales, a small disruption can ripple outward. This is not fragility in the sense of weakness, but interdependence. A system evolved to precision now finds itself adjusting to something new. Still, the creatures here persist, not through denial, but through deep instinctual commitment. Each cycle of life here, each birth, each dive, each egg passed foot to foot, is an act of resilience. Not in defiance of the cold, but in harmony with it. There's something deeply grounding in that, in knowing that, while the human world spins ever faster, while noise and urgency fill the air, somewhere in the far south, a penguin still stands in the dark, holding an egg on its feet. A seal swims under stars it cannot see. A whale moves through green-black water, guided by ancient roots. Life in Antarctica is not loud. It is not fast, but it is full of rhythm and meaning and time, and that perhaps is why it moves us so. We often look up when we imagine alien life, into the blackness between stars toward distant planets and glowing moons. We scan skies for radio signals, point telescopes at dim red suns, build machines to fly beyond the edge of Earth's warmth. But sometimes, to imagine life beyond this world, we have to look down, deep beneath our own ice. Because some of the most promising lessons about extraterrestrial habitability are being whispered right now by the frozen silence of Antarctica. It's not just poetic, it's practical. Places like Lake Vostok, Lake Whillans and Lake Mercer are analogues, Earth-based laboratories where we learn how to explore extreme environments without disturbing them. These subglacial lakes, sealed beneath miles of ice, mimic in many ways the conditions believed to exist on Europa, one of Jupiter's moons, and Enceladus, orbiting Saturn. Both of these icy moons are thought to have liquid oceans beneath their frozen crusts, warmed not by sunlight, but by internal heat generated through tidal flexing, pulls and tugs from their parent planets that stir and warm their interiors. And while we can't drill into Europa just yet, we can drill into Antarctica. Every borehole we create here is a test, not only of engineering, but of restraint, of how to access without corrupting, of how to enter without erasing. The techniques developed to explore Antarctic lakes, hot water drilling, sterile probes, real-time contamination checks, are laying the groundwork for future missions to these alien seas. But the connection runs deeper than technology. What Antarctica teaches us is not just how to explore life elsewhere, but what life might look like when it appears far from the familiar. The microbes found in subglacial lakes do not photosynthesize. They do not breathe oxygen in the way we do. They thrive in pitch blackness, surviving on chemical energy drawn from minerals in the lake bed, iron, sulfur and other elements slowly weathered from ancient rock. This kind of chemosynthesis is likely the best candidate for life elsewhere in our solar system. In that way, Antarctica is a whisper from a possible future. A place that says softly, yes, life can exist without sunlight, without warmth, without air. If it can arise here, it might arise there too. Mars is another comparison. Once wet, now frozen, with evidence of ancient riverbeds, lake basins, and possibly underground water today. And though its surface is dry and irradiated, its subsurface, like Antarctica's, is more protected. If life ever existed on Mars, or still does, it's likely in hidden aquifers, or in brine pockets beneath the polar caps. The search for that life begins with what we learn in the south. And there's something philosophical in this connection. We often think of Earth as the warm, blue planet, lush and inviting. But parts of it are as alien as anywhere in the solar system. Antarctica is not a familiar wilderness. It is a reminder that our planet too holds secrets we do not fully understand. That alien is not a matter of distance, but of perception. The ice teaches us humility. Its lakes are not eager to be found, its microbes do not announce themselves, its ecosystems thrive without notice. And yet, here we are, listening, drilling, observing, hoping. Not for spectacle, but for understanding. And understanding requires stillness. That stillness is what shapes the mindset of astrobiology. When we send a probe to Europa, or collect data from Martian regolith, we are not just looking for signs of life, we are looking for the possibility of it. And possibility is quiet. It builds slowly across evidence and doubt, like frost forming on a window. The parallels are uncanny. Beneath Antarctic ice, we see environments isolated for millions of years. On Europa, scientists believe the ocean has been sealed beneath ice for potentially 1 billion. On Earth, chemosynthetic microbes feed on minerals. On Enceladus, plumes erupt into space that contain hydrogen, methane, and complex organic molecules, ingredients that could feed similar metabolisms. If we have learned anything, it's that life finds a foothold not in comfort, but in potential. In chemistry, water, and time. And so, Antarctica is not only a continent, it's a lens, a stage, a rehearsal for the grander drama we might one day observe elsewhere. Every ice core, every sealed lake, every patient microbe is part of a quiet script we are only just beginning to read. And if we hope to understand alien life, we must first listen carefully to the alien lives already among us. It doesn't mean they're from another planet. It means they teach us how big life can be, even when it's small. How strange life can be, even when it's familiar. How stubborn and beautiful and gentle. So the next time you imagine explorers on Europa, walking across blue-white ice under a distant sun, picture also the scientists here, cold, focused, holding a sterile probe above a hole in the Antarctic crust. Picture the silence, the breath held, the drop of water lifted, trembling with age and potential. This is how it begins, not with alien greetings, but with Earth learning to recognize itself in forms it almost forgot. There is a place in West Antarctica where the ice no longer waits. It moves, slowly, yes, quietly, for now, but with a certainty that stirs even the calmest voices in the scientific world. They call it Thwaites Glacier, though many now know it by another name, the Doomsday Glacier. Not because it brings immediate catastrophe, or loud explosions, or anything theatrical, but because, should it collapse fully, it may change coastlines around the world. Not in one day, but in 1,000, and then forever. Thwaites is enormous, a frozen river of ice wider than the state of Florida, stretching more than 100 kilometres across and over a kilometre thick in places. It flows from the vast interior ice sheet of West Antarctica and empties into the Amundsen Sea. But Thwaites is more than just a glacier. It is a keystone, a load-bearing wall holding back even larger sheets of inland ice. Its integrity matters not just for Antarctica, but for every city that kisses the sea. For decades Thwaites held. Ice flowed, as ice does, slowly, steadily, reshaped by gravity and seasons. But then, something changed. Satellites watching from above began to see its grounding line retreating, the invisible point where the glacier lifts off the seabed and begins to float. That line, once stable, has been moving inland at an accelerating pace. Beneath the glacier, warm ocean currents have crept in through undersea troughs, licking at its belly, melting it from below. This is not heat we feel in the air. It is hidden warmth circulating beneath the ice, out of sight but not out of consequence. And as that base melts, the glacier loses its grip. It becomes lighter, more buoyant, more prone to collapse. Scientists describe what's happening as a kind of marine ice sheet instability, a chain reaction where retreat makes more retreat inevitable. Like a row of dominoes placed carefully and now beginning to tilt. The numbers are sobering. If Thwaites alone were to collapse completely, global sea levels could rise by over 60 centimetres. But that's just the beginning, because behind Thwaites lies more ice, connected, pressurised, held back by the glacier's slow resistance. If that resistance fails, the surrounding glaciers may follow, and the potential sea level rise could then exceed 3 metres, enough to redraw the edges of continents, to reshape the maps on every classroom wall. But Thwaites doesn't shout. It doesn't crack like thunder or crumble in a single sweep. It pulls back inch by inch, month by month, year by year. The danger lies in how silently it moves, and in how delayed its effects may be. To the casual observer, nothing seems urgent. To the satellite, however, the pattern is unmistakable. And scientists are listening. They fly over it. They lower sensors beneath it. They measure its meltwater, its flow speed, its seismic murmurs. In 2021, a team drilled through the ice to deploy instruments directly into the grounding zone. What they found confirmed their fears. The glacier is losing its grip faster than expected, melting even during the cold Antarctic winter. So why is this glacier, tucked away at the bottom of the world, so important to you and me? Because Thwaites connects Antarctica's deep time to our very current lives. Because the rise of water is not theoretical. For millions living in coastal cities, Bangkok, New York, Lagos, London, Jakarta, the melting of Thwaites is not abstract science, but a question of futures, of homes and harbours, of which parts of the city will still be dry when a child born today reaches adulthood. And yet there's something uniquely sobering about Thwaites. Unlike a hurricane or wildfire, there is no emergency broadcast, no moment when the damage becomes undeniable. The threat unfolds slowly, not in minutes but in decades. It asks us not for panic, but for wisdom, for the ability to act not just for today, but for the world beyond our lifetimes. Some still hope that internal features within the glacier, ridges and underwater pinning points, might slow its collapse, giving time for adaptation. Others suggest it may be past a tipping point, a threshold already crossed, whose full effects won't be felt until it's too late to intervene. But this is not the story of despair. It is the story of attention, of watching a glacier move, not in fear, but in understanding. And perhaps, if we listen closely to Thwaites, if we take seriously what it shows us about warming oceans and silent thresholds, we can still shape the future it foretells. We tend to think of glaciers as static, as immobile walls of ice, timeless and stoic. But they are not. They move, they breathe, and sometimes they break. And when they do, the oceans remember. If glaciers are rivers of slow-moving ice, then ice shelves are the quiet deltas where those rivers meet the sea. Flat, wide and seemingly serene, these floating platforms extend out from the Antarctic mainland, forming vast frozen bridges that hover just above the Southern Ocean. They look still, they feel permanent, but in truth, they are holding something back, something heavy, ancient, and always pressing forward. Ice shelves are the unsung guardians of Antarctica. Their role is not dramatic, but it is essential. They act as buttresses, bracing the glaciers behind them. As long as these shelves remain intact, they slow the glacier's flow, anchoring inland ice in place. But when they weaken, when cracks widen or meltwater seeps in, or their underbellies are warmed by rising seas, those barriers collapse. And once gone, there is little left to hold the glaciers back. We've seen this before. In 1995, Larsen A, a small ice shelf on the Antarctic peninsula, disintegrated. It was dramatic but isolated, just one edge of a vast frozen continent. Scientists observed, took notes, and continued their work. But in 2002, something much larger happened. Larsen B, a shelf roughly the size of Rhode Island, collapsed in the space of weeks. A satellite image from February that year showed the shelf mostly intact. By March, it was a flotilla of shattered icebergs drifting northward. The speed of the collapse startled even seasoned researchers. It was not slow erosion, it was sudden failure, and the consequences were clear. In the years that followed, the glaciers once braced by Larsen B began to accelerate, flowing 2 to 3 times faster into the sea. It was a vivid demonstration of what happens when an ice shelf disappears, the equivalent of cutting a rope and watching a heavy load slide downhill. The next chapter in this unfolding story is Larsen C, an even larger shelf that partially fractured in 2017. A massive iceberg, known as a 68, broke free, one of the largest ever recorded, with a surface area over 5,800 square kilometres. Though Larsen C has not fully collapsed, the event marked another threshold. Each fracture, each carving event, tells us something about the changing strength of the ice. So why are these shelves failing? The answer, gently, is heat, but not just from the sun. While atmospheric warming plays a role, especially in forming surface melt ponds that can drive crevasses deeper, the more insidious threat comes from below. Warmer ocean currents, strengthened by shifting wind patterns and climate cycles, are creeping under the floating shelves. They eat away at the ice from the underside, hollowing it out in ways that are invisible from above. This process is part of what scientists call basal melting. It doesn't produce dramatic images, no great cracks or tumbling cliffs, just a slow thinning, like a bridge quietly losing its supports. And then there's the albedo effect, the feedback loop of the light and warmth. Ice in its natural state is bright and reflective. It bounces sunlight back into space, helping keep Earth cool. But as shelves break up and expose darker ocean water, the balance shifts. The sea absorbs more heat, accelerating ice loss in a cycle that feeds itself. What was once resistance becomes retreat. The ice shelves, then, are not just passive structures, they are active participants in Earth's climate equilibrium. Their collapse isn't just a local event, it echoes outward, influencing ocean circulation, sea level rise, and even weather patterns far from the poles. And yet, they do not call attention to themselves. They don't roar like volcanoes or flash like lightning. Their language is creaking, cracking, drifting. Their vocabulary is one of melt rates, thinning zones, stress fractures. And it's up to us to translate that language, to listen with satellites, to model with equations, to observe patiently and quietly. There is a lesson in their stillness. That strength is sometimes not a matter of noise or movement, but of holding. Ice shelves hold back time. They delay change. They offer us the precious gift of slowness in a world that often rushes forward too quickly. But that gift is not unlimited. If shelves like Ross and Filchner Ronne, some of the largest in the world, begin to weaken substantially, the implications will extend far beyond Antarctica. These are the platforms holding back some of the thickest glaciers on Earth. Their collapse would not raise seas overnight, but it would open the gates, setting in motion a process that could unfold over centuries, lifting shorelines metre by metre. It's a reminder that not all turning points arrive with a bang. Some come with a quiet break, a melting edge, a slow drift of ice into a warming sea. So tonight, as you drift towards sleep, imagine standing at the edge of one of these great shelves, the air cold, the light silvery and soft. Beneath your feet, ice as old as memory, and beneath that, water warmed by a sun you cannot see, moving slowly, changing everything. In most places on Earth, you can trace the cause of change to something visible: a drought, a fire, a storm. But in Antarctica, change often begins with movements you cannot see. It is the wind, skimming low over the Southern Ocean. It is the water, warmer by a fraction of a degree, slipping quietly under the ice. And it is the ancient current that circles the continent endlessly, indifferent and unstoppable. This is the Antarctic story not of stillness, but of motion. At the heart of this quiet choreography is the Antarctic circumpolar current, the most powerful ocean current on the planet. It flows from west to east, completely encircling the southernmost continent, unbroken by land. This vast ribbon of water transports heat, salt, and momentum, acting like a planetary belt that connects the Pacific, Atlantic, and Indian Oceans. It is deep, wide, and strong, moving more water than all the world's rivers combined. And it matters, not just to the polar regions, but to the global climate system. This current doesn't just flow, it interacts with the atmosphere above, with the sea ice floating on top, and most crucially, with the underwater topography that shapes its path. As the current brushes against the seafloor's ridges and troughs, it can send eddies and fingers of warm water inward, sneaking past the outer shelves of ice, drifting slowly toward the glacier's bases. These warm waters, part of what scientists call a circumpolar deep water, are a subtle but potent force. They don't boil, they don't crash, but they erode, quietly, persistently, and over time they reshape the base of Antarctica. But how does this water, buried beneath kilometres of ice and ocean, get there in the first place? Part of the answer lies in wind, specifically the westerly winds that circle Antarctica. In recent decades, those winds have intensified and shifted southward. This is partly a result of human-driven climate change and partly due to natural variability. As the winds shift, they alter the surface currents, which in turn draw warm, deep water upward and toward the continental shelf. It's like lifting a lid and letting something warmer reach the cold base. And once that warmth arrives beneath the ice shelves, the consequences begin. Melting starts from below, a kind of invisible unravelling. The shells become thinner, more fragile. The grounding lines retreat. The flow of inland glaciers speeds up. All of this because of changes in wind patterns and water paths, forces that seem distant and impersonal, and yet reach deep into the heart of the ice. What's remarkable is how these systems are not just interacting, they are dancing. Ocean, wind, and ice move in a loop of influence. The wind drives the ocean shapes the ice, and the ice, by melting or reflecting light, feeds back into the system. This isn't a single cause with a single effect. It's more like a waltz of invisible partners, each responding subtly to the other's step. Sometimes that dance leads to balance. Antarctica has, for much of its history, been a masterclass in equilibrium, where cold air, sea ice, and ocean currents formed a self-sustaining cycle of freeze and thaw, flow and hold. But now the rhythm is changing. The warmth moves in just a little faster. The winds swirl just a little stronger, and the feedback loops that once stabilised the ice are now shifting their tune. Still, the changes remain slow enough to be missed by the naked eye. You could stand on a glacier and feel nothing. You could look out at the sea and see only blue. But beneath your feet, and beyond the horizon, the patterns are shifting. It's in the data, in the satellite altimetry that shows thinning ice shelves, in the radar maps that reveal melt channels underneath, in the temperature profiles taken by probes and submersible robots. We're now able to witness the unseen, because we have learned to listen differently. And what we hear is a planet in motion, not in crisis, but in conversation. A conversation between elements older than language. There's something humbling in that. We tend to imagine the planet as a set of boundaries, continents, countries, climate zones. But beneath those boundaries, the Earth breathes as one system. The wind that moves over your city may have once swept over Antarctic waters. The ocean that laps at your shore is stirred by currents born near the South Pole. Even the weather patterns you wake to may carry fingerprints from the polar jet stream, shaped by Antarctic air. And so, when we speak of Antarctica melting, we're not describing something happening over there. We're describing a shift in the planet's pulse, a change in the rhythm we all share. It's easy to feel disconnected from this great choreography. But perhaps that's only because it is so vast and so quiet. When you zoom out far enough, you see that nothing on Earth truly stands alone. That wind and wave, ice and current, are all part of a deeper pattern, a pattern that holds us too. So tonight, as you listen to the wind outside your own window, know that it may be part of that very dance, a soft breeze born of ancient air, moving gently through time, just one note in a planetary song that never ends. There are few things in this world older than Antarctic ice. It predates the rise of cities, the formation of nations, the carving of rivers we now call familiar. Layer by layer, flake by flake, it has built up over hundreds of thousands of years, each snowfall pressing softly into the one beneath, each breath of ancient air becoming a tiny time capsule. And so, in its frozen stillness, the ice remembers. It remembers in silence, in depth, in chemistry. It holds within it a record of the world as it was, year by year, storm by storm, eruption by eruption, and just as books are written in ink, the ice writes its memories in bubbles. These bubbles, trapped between snowflakes as they were compressed into firn and then into solid glacial ice, contain actual molecules of the atmosphere from long ago, tiny sealed pockets of air, perfectly preserved for tens, even hundreds of thousands of years. When scientists drill ice cores from the Antarctic interior, what they are extracting is not just frozen water. They are reaching back in time, reading Earth's breath from ages past. Some of the deepest cores ever drilled, like those from Dome C on the East Antarctic Plateau, reach back nearly 800,000 years. In those cores, researchers have found vivid signatures of ancient climate shifts, evidence of ice ages coming and going, carbon dioxide levels rising and falling, temperatures warming and cooling in slow cycles that echo the dance of Earth's orbit around the Sun. And what's remarkable, what makes the ice not just a witness but a teacher, is the pattern. The way carbon dioxide and temperature rise together, fall together, cycle together over millennia. It's a relationship written in air, long before humans ever learned to read it. But then something changed. Roughly 200 years ago, during the dawn of the Industrial Age, the balance begins to break. In the most recent layers of ice, and now even in atmospheric measurements directly, we see carbon dioxide rising faster than at any point in the past 800,000 years. Not gently, not cyclically, but steeply, unnaturally. A spike, not a curve. It's like listening to a symphony and suddenly hearing a discordant note. Sharp, loud, out of rhythm with everything that came before. The ice records it all, quietly, without judgment, just as it recorded the volcanic ash from distant eruptions, or the faint dust from Saharan winds that somehow made their way south, or the subtle traces of leaded gasoline decades ago. The ice listens, and it does not forget. But there is more to these frozen records than just gas. In the ratios of isotopes, scientists can read past temperatures. In layers of dust, they infer wind patterns and aridity. In traces of pollen or salt or volcanic glass, they piece together stories of landscapes, of oceans, of atmosphere. The ice, in other words, does not just tell us what the Earth was like, it shows us how it changed and how fast. This matters. Because when we compare the changes we're seeing now, the melt, the thinning shelves, the warming seas, to what the ice remembers, we find something new. Not just that the planet is warming, but that it is warming faster than it has during any previous natural cycle. The ice has known warmth before, it has seen CO2 rise, but never like this, never with this speed. And that is the quiet warning it gives us. Not in alarm bells or shouting headlines, but in a simple frozen truth. We're no longer walking the familiar path. The world is changing, yes, but not in the old rhythm, in a new one. And the ice, the most patient of observers, has taken note. But there is also a strange comfort in this, because in reading the ice we remember something else. The Earth has been through transformation before. Ice ages have come and gone. Forests have risen and fallen, oceans have shifted. Species have adapted, migrated, disappeared, reappeared. The world is not fragile in the way we are, it endures. What is fragile, perhaps, is our place within it, our coastlines, our crops, our seasons, our expectations. The structures we've built, assuming that the climate would stay roughly the same, these are the things that tremble when the ice begins to speak. But knowing is power, quiet power. Because when we listen to the ice, when we truly hear its story, we can make better decisions, not just for ourselves, but for those who will walk this earth long after us. The ice may hold memory, but we hold the power to shape what comes next. So tonight, imagine that you are standing beside a core sample in an Antarctic lab. The room is cold, humming softly with refrigeration. Before you, a long cylinder of ice, clear, smooth, ancient. You lean in, you look closely, and there, inside, a single air bubble, trapped, unmoving, carried forward through time to tell you something. Not everything has to be loud to matter. Some warnings come in whispers, some memories live in snow, and when the ice speaks, we would do well to listen. We tend to think of Antarctica as eternal ice, a land always frozen, always white, always silent. But beneath its cold armour lies a deeper truth, a memory so vast it spans worlds we barely recognise. Antarctica was not always a continent of snow and stillness. Long before it became the coldest place on Earth, it was green. It breathed. It bloomed. To imagine that may feel like a stretch, but the fossils do not lie. In the rocks hidden below the East Antarctic ice sheet, those glimpses of stone only briefly exposed at the fringes of the continent, scientists have found something extraordinary. Tree trunks, fossilized and upright, leaves pressed flat into stone, ferns familiar in shape and texture but millions of years old. These are not marks of drifting seeds or coastal debris. They are the remnants of full forests, once rooted deeply in Antarctic soil, and not just plant life. Deeper exploration has revealed the bones of ancient amphibians, frog-like creatures, their skeletons preserved from a time when Antarctica was part of Gondwana, the great supercontinent that once linked South America, Africa, India, Australia and Antarctica in a single sweeping landmass. It was a very different world then. The Earth's climate was warmer, sea levels were higher, dinosaurs roamed above, and primitive mammals stirred below. Antarctica sat further north, not yet isolated by ocean currents. And though the sun still vanished in winter, the summers brought long periods of daylight and relative warmth, enough to sustain dense vegetation, swampy wetlands, and animal life. The image is almost dreamlike. A green Antarctica thick with trees, their branches swaying under long golden light, rivers running across open valleys, frogs croaking beneath ancient ferns, insects buzzing in the damp air. It seems like another planet, and yet it is the same land we know today, only colder, quieter, sealed. Over millions of years, tectonic drift pulled Antarctica southward. Climate cycles cooled. Currents formed around the continent, isolating it in a ring of cold. Snow fell, ice formed, centuries passed, millennia. And those living landscapes, those forests, those rivers, were slowly buried, not erased, not destroyed, but entombed. In that way, Antarctica is not just a place. It is a time capsule, one that holds within it the memory of a greener Earth, waiting patiently beneath the cold. The ice above is thick, but not infinite, and below it, the rocks remember. Radar surveys have mapped out ridges and basins that were once rolling hills and open plains. Geologists speak of the Transantarctic Mountains, not new formations, but ancient ones, shaped before ice ever touched them. The valleys carved by prehistoric rivers are still there, hidden under kilometres of glacial crust. In some places, scientists believe there may even be preserved soil, frozen in time for millions of years. And with each discovery, the story grows richer. Not just a tale of loss, but of transformation. Because in that memory lies a message. If Antarctica could change this much, if it could go from lush to frozen, from frogs to frost, from sunlight forests to snow-swept deserts, then the Earth itself is far more dynamic than we often allow. It evolves, it turns, it surprises, but it also endures. The fossilized trees do not rot, the ancient rocks do not crumble. They wait quietly beneath their icy ceiling, whispering of things that once were. It's humbling to think that the very ground beneath the South Pole once hosted ferns and running water, that the frozen silence we now associate with the end of the world was once part of its vibrant core. Antarctica doesn't just store ice, it stores time, layered, compressed, composed like music in stone. And while we can't yet walk freely across those lost landscapes, we can sense them, in the rocks collected from rare outcrops, in the pollen grains embedded in sediment, in the oxygen isotopes that tell of temperatures long gone, in the tiny hints of carbon, maybe once part of a leaf that lie dormant, waiting for someone to notice. And we have noticed. Every expedition, every drill, every scan reveals another piece of the puzzle. Antarctica is not a blank space. It is not just a void of white. It is a palimpsest, a layered manuscript, where past climates and ecosystems are written beneath the surface. It reminds us that stillness does not mean absence, that silence is not emptiness, that even the quietest places can be full of story. So the next time you picture Antarctica, try not to see just ice. Imagine the forest beneath it, the rivers that once ran free, the creatures that called it home, and then imagine the ice forming above them like the closing of a book, protective, slow, unread for ages. The continent hasn't forgotten, it has simply been waiting. If you could peel back the ice from Antarctica, like lifting the lid from a long-sealed box, you'd find something unexpected waiting underneath. Not just rock and dust, but a hidden map. A map not drawn by human hands, but carved by water long ago. Rivers that no longer run, valleys that no longer echo, paths etched in ancient soil, now asleep beneath kilometres of frozen weight, and yet, despite their silence, they still speak. Much of this hidden landscape remained unknowable until recently, but thanks to advancements in satellite radar and ice-penetrating technologies, we now have a kind of X-ray vision, a way to glimpse what lies below. And what these images reveal is staggering. Deep river channels, some hundreds of kilometres long, winding beneath the ice like veins beneath pale skin. Wide basins sculpted by flowing water long before the first flake of snow ever settled on this land. Canyons deeper than the Grand Canyon, ridges, deltas, tributaries, all buried but not erased. They call them paleo river systems, ghost rivers. Their beds lie dry now, filled with silt or sealed in ice, but once they carried water across a green Antarctica. These were not trickles or glacial melt streams. These were full flowing rivers coursing through forests and wetlands, connecting lakes and feeding life. There is one valley in particular, traced through the Gambutsev Mountains, that stretches for hundreds of kilometres beneath the East Antarctic ice sheet. It is so vast and so deep that scientists once mistook it for a tectonic rift. But it isn't a crack in the earth. It's a memory of water that moved through a world before the ice came. These riverbeds tell us more than just where water once flowed. They hint at climate, at elevation, at life. The shape of a valley tells you how water carved it, how quickly it ran, how often it flooded, how long it endured. In places where sediment is preserved, scientists hope to find grains of pollen, spores, even traces of microbial life, tiny signatures of a forgotten biosphere. And yet most of these systems remain untouched, unreachable. They lie beneath ice that is 2, 3, sometimes 4 kilometers thick. Ice that moves slowly but constantly. To drill into it without disturbing what lies beneath is a monumental challenge. And so, for now, we observe from above. We trace outlines. We model flow paths. We imagine the rain that once fell there, the pools that once reflected light. In a strange way, these buried rivers feel more like memories than geography. They don't announce themselves. They don't shape our maps or our journeys, but they exist in the background, lines left behind by time softly carved into the body of the continent. And there's something profound in that, because it reminds us that even water, which we often associate with motion, can leave lasting marks in stillness. A river does not need to flow forever to be remembered. A valley does not need to echo to be real. Antarctica, in this sense, is not just a place of snow and ice. It is a continent of shadows, ghost topographies, visible only through instruments and inference. And those shadows are full of stories. Not just of what once lived, but of how it lived, where it gathered, how it moved, where it rested. These discoveries also give us something more, a glimpse into Earth's future. Because just as the ice has covered these valleys, it may one day uncover them. If the warming continues, if glaciers retreat, if shelves collapse, these buried landscapes could be revealed again. And when they are, what will we see? Perhaps the dry beds of rivers that haven't run in 30 million years. Perhaps the imprints of tree roots in fossilized soil. Perhaps the shape of an ancient lake, its edges still clear beneath the receding ice. And perhaps, just perhaps, we'll understand something about our own patterns, how we come and go, how we build and collapse, how even the most flowing parts of us can leave something solid behind. The valleys beneath Antarctica are not just relics. They are reminders that change can hide, that memory can settle into stone, that some things, even when buried, are not lost. Imagine standing on the surface of Antarctica, where all you see is white stretching to the horizon. But now, picture that beneath your feet lies a riverbed, long dry, its curves still elegant, its path still clear. Imagine it carrying water during a time when mammals were just beginning to rise, when birds were learning to soar, when flowers were new to the earth. It's all still there, silent, preserved, waiting, like a message written in a language we're only just beginning to relearn. There are kinds of silence that feel empty, and kinds of stillness that feel like waiting. Antarctica, more than any other place on Earth, reminds us that silence is not absence. It is attention. It is memory made dense. It is presence stretched across time. We often imagine danger as something loud, a storm, an eruption, a wave, something that breaks the calm. But the most profound changes in the world don't always arrive with sound. Sometimes, the quietest places are the ones trying hardest to tell us something, not by shouting, but by enduring. When you look at a satellite image of Antarctica, it seems fixed, a white continent curved and unwavering, like a pause button pressed at the bottom of the earth. But beneath that stillness, beneath the snow that seems untouched, and the sky that seems unchanged, is a slow-motion transformation. Glaciers thinning, rivers melting, temperatures rising half a degree at a time. It is the kind of change that does not knock. It whispers. Stillness, in this sense, is not a void. It is a signal. Antarctica does not act quickly. It is not impulsive. It moves in ages, not hours. And so, when it does begin to move, when the balance shifts even slightly, we must pay close attention. Because for a system so vast, so cold, and so patient, even a small signal is significant. It's like watching the first flake fall before a blizzard, or noticing the way a pendulum pauses just before reversing direction. The moment is quiet, but full of potential, full of weight. Antarctica speaks in these kinds of moments. A calving shelf, a retreating glacier, a core of ice revealing a carbon spike, not thunder, just threads. Threads that, if you follow them long enough, reveal a tapestry of change. There's also a kind of beauty in the slowness. We live in a world that values speed, fast communication, fast travel, fast decisions, but Antarctica doesn't rush. It asks us to slow down, to listen differently, to feel the way time stretches when it's not being divided into hours and deadlines. Here, days are long, sometimes endless. Nights last for months. Change moves like the tide beneath a frozen lake, unseen but constant. And in that slow rhythm, there is clarity, because stillness gives space for thought, for understanding. It allows the weight of things to settle. There is a reason why so many who visit Antarctica speak of it in spiritual terms, not because they found answers, but because they heard themselves differently in the quiet. They felt, perhaps for the first time, what it meant to be small in a generous way. To be part of something that does not revolve around them. It's in this stillness that Antarctica becomes a kind of teacher, not in the way of lectures or instructions, but in example. The ice does not resist its surroundings. It adapts. It flows when warmed. It freezes when cooled. It holds memory but does not cling to it. It waits. It watches. It reflects more light than it absorbs. It shows us what happens when something stays, not because it must, but because it can. And in that lesson is a subtle challenge to us. Can we listen without speaking? Can we observe without intervening? Can we hold still long enough to learn something, not about ice, but about ourselves? Stillness is not inaction. It is deliberate presence. It is the glacier that holds its shape for centuries. It is the wind that circles endlessly without landing. It is the seal that rests on the ice, unmoving, but alert to every sound beneath the surface. It is the way a snowflake settles, unhurried and unnoticed, and yet adds its weight to something ancient. So when we look at Antarctica and call it lifeless, we are missing the point. Its life is just not animated in the ways we're used to. It unfolds in different rhythms, in colder colours, in deeper time. What we call desolate may, in fact, be a form of attention we've forgotten how to recognise. And perhaps that is the final signal, that in this era of acceleration, when everything urges us to move faster, think quicker, act now, there is still a place that holds a longer view, that remembers what we've forgotten, that teaches simply by continuing to exist. So tonight, as you breathe and the room quiets, let yourself drift into that same stillness. Let the silence stretch a little. Let time expand. There's no need to rush toward the ending. Antarctica wouldn't. Stand at the edge of Antarctica, not just physically, but imaginatively, and look not into its ice, but into its reflection, because that is what this continent has become, a mirror, the quietest mirror on Earth. It doesn't move with you or distort your image. It doesn't shimmer or shout back. But it shows us things we would rather not see. Not in the details of glaciers or the length of melt seasons, though those are part of it. What it reflects is subtler, more intimate. It reflects us. It shows us what we've done, not only to the world but to time, to balance, to scale. In the curve of a collapsing shelf you can see the trace of fossil fuels burned half a planet away. In the thinning of a glacier you can glimpse our assumptions, that ice would stay, that the seas would wait, that nature was a backdrop rather than a character. In the temperature of the ocean beneath that ice, you find the slow imprint of industries, economies, and choices too complex to name but too powerful to ignore. And yet the mirror does not accuse. Antarctica does not need us. It has no politics, no currency, no need for affirmation. It was here before us. It will be here long after. Its silence is not resentment, it is patience. A patience that lets us approach, lets us measure and marvel, even as we change it in ways we cannot fully undo. Still, the reflection lingers. Because in that silence, we also see something else. We see potential. Not for repair necessarily. Not all damage can be reversed, but for recognition, for humility, for a new kind of belonging. To stand in Antarctica, or even to think of it, is to feel a kind of smallness that is strangely comforting. It reminds us that we are not the centre of the story, not of Earth's, and not even of our own. We are one part, one moment, one warm breath on a cold pane of time, and there is beauty in that, because when we step back from the illusion of control, we begin to see connection. The warmth that reaches under the glaciers begins as wind in another hemisphere. The soot that darkens a patch of snow may have risen from fires lit continents away. Even the gases trapped in ancient ice now meet their descendants in the sky above, circling the globe in invisible loops. We are, for better or worse, entangled. So the mirror reflects not only our impact, but our influence. The kind we often underestimate. The kind that builds slowly, like climate, like trust, like memory. Antarctica shows us that what we do matters not because the world reacts immediately, but because it remembers. And that makes the choices we face not just environmental, but ethical. How do we treat a place that asks nothing of us? How do we care for a continent that cannot protest, but quietly alters in response to our presence? How do we behave in the face of silence? Perhaps that's the final lesson of this cold mirror. It's easy to act in a world that answers back. Feedback is familiar. If a place yells, we respond. If it burns, we react. But Antarctica asks for something more difficult. To listen without prompting. To care before being asked. To preserve not because we are forced to, but because we choose to. And in doing so, we might just find that the reflection changes. Not because the ice has melted or stayed, but because we begin to see differently. We begin to see the continent not as remote, but as a part of the same living, breathing system we inhabit. Not as a blank spot at the end of the map, but as a voice at the centre of the story. Quiet, but necessary. So when you next hear the word Antarctica, let it mean more than cold. Let it mean witness. Let it mean mirror. Let it mean a vast and silent yes to everything the world once was and might still become. Let it mean the Earth has not stopped watching, and neither should we. And so, we've reached the quiet edge of our journey. We've wandered through frozen valleys and beneath glaciers older than memory. We've listened to the whispers of buried lakes, watched the slow breath of collapsing shelves, and touched, however briefly, the contours of a world that speaks in ice, not words. Now, the winds settle. The questions drift like snow. There is nothing more to prove, only something to feel. Imagine yourself now beneath the Antarctic sky. The light is low, soft and blue, stretched wide like a sheet pulled gently over the world. The snow underfoot is not cold anymore. It's simply quiet. The kind of quiet that doesn't demand anything from you. The kind that says, "You've seen enough for now. Let the rest wait." Far above, the stars blink through the thin polar air. There are no streetlights here, no engines, no ticking clocks, just the slow rotation of Earth beneath the cosmos, the planet turning like a sleepy child, shifting in its sheets. And in this vastness you are not alone. You are cradled in a stillness that is held for eons. The ice is still there. Even if you close your eyes, even if you drift off completely, it remains, watching, remembering, holding. All the rivers beneath, all the fossils, all the messages pressed into snowflakes and trapped in bubbles of breath, it's all still there, like a story paused mid-sentence, waiting for the next reader to arrive. Antarctica doesn't mind your forgetting. It has waited through warm ages and frozen ones. It has waited while continents split and storms passed overhead. It can wait a little longer while you rest. You've walked through time tonight. From blooming forests that once covered this land to the alien quiet of microbial life beneath sealed lakes. From the crashing birth of volcanoes beneath the frost to the spectral map of rivers long vanished. From the slowness of melt to the urgency of memory, you've travelled without moving, and yet you've arrived somewhere deeper, somewhere still. And now perhaps it is time to stop wandering, not because there is nothing more to discover, but because the body and mind need rest to hold what they've gathered. Think of the glaciers as blankets, heavy, yes, but comforting. They press down not to smother but to preserve, to keep ancient things safe. In that same way, let your breath settle like snow. Let each inhale be a snowfall, each exhale a sigh of drifting warmth. The world will not forget you while you sleep. The stars will not vanish. The continent will not crumble beneath your dreaming. Everything you've heard tonight, every frozen thought and buried question can wait. That is the strange magic of Antarctica. How it holds time open, like a door that doesn't close. A place where even forgetting becomes a form of remembering. And so now, as your eyes grow heavy, let go of names, let go of questions, let go of the noise of knowing. Let the last thing you hear be not a fact, not a date, but a feeling of space, of hush, of slow turning sky above a continent that never asks to be found, only noticed. Sleep well, little wanderer. The secrets will wait. They always have.